We are Entras. Together, we build software for controlling flexible assets for the industry.
We strongly believe that the future will be flexible. Any industry, big or small, any building, any home will make use and make profit out of flexibility.
That future starts now. In this podcast series, Flexing the Future, we share our insights on flexibility.
Welcome to our podcast Flexing the Future. Today we will discuss the business case of industrial electrification. Next to me are my colleagues Jeroen and Jens, and I am Frank from Entras. So let's start off. Jeroen, what is meant by industrial electrification?
Well, in general, in industry, the energy demand of industry is typically one third electricity only, or sometimes 1/4, and so the rest is typically gas or some other sources. And by electrification, typically we mean that we increase the share of electricity that is used in the energy mix, and of course with the advantage of electrifying means higher efficiency, but also means that we can use renewable energy because that directly makes electricity. So electrification typically is an energy transition topic where we can use more renewables directly, but that means a shift from fossil fuels typically towards electricity.
Yeah, so it's all about avoiding CO2 emissions.
Yeah, I think it's mostly about avoiding CO2 emissions, although you can earn money with it. So it can just also be a pure economic driver more and more.
Yeah. And in these days, maybe also a geopolitical driver.
Yes, because we don't really have a lot of fossil fuels in Europe, while we do have resources, renewable resources we can tap into. So there is also a ever-increasing geopolitical component, yes.
Right. So, but the reason we want to talk about the business case of industrial electrification is that a lot of people, companies, they try to change their fossil boilers and whatever by electrical equipment, and I see then, it's getting very expensive.
Yeah, maybe I can comment a little bit. First of all, there are always two aspects to a business case. So there is the investment, the capex part, and then there is the operational cost. So maybe first on the operational cost. Of course, in general, there is electricity on average is more expensive than gas still today. It's what we call in the sector the spark spread or the clean spark spread. So, of course, if you would change a baseload gas boiler by a baseload e-boiler, you could roughly say that your energy cost will double because electricity is still almost twice as expensive as gas. So that is not really what is helping now. Maybe in the future, when that link is broken, if the system is mainly driven by renewables, then electricity could become, on average, cheaper. What we see now is that electricity sometimes is cheaper. I don't know, maybe
and it's
you
all
can comment to that.
The fluctuating energy prices, which are of importance, I think, for a business case. So on average, indeed, as you say, electricity is twice as expensive as fossil gas. But in fact, electricity prices are really volatile, so meaning that they differ from hour to hour. And you have more and more hours where the electricity is cheaper than fossil gas. And that's, I think, the interesting thing of putting an e-boiler, for example, next to a gas boiler, fossil gas boiler, is that those cheap hours, you can use the electric boiler to make your heat for your industry.
And how is that these cheap hours or negative hours or just cheap hours, how are they evolving? And let's say a few years ago, there were not too many let's say low price hours. How do you see that?
Well, this is all linked to indeed the renewables. Renewables are increasing year on year. Multiple gigawatts of wind and solar are installed in Belgium, but throughout Europe. And it's those renewables who are driving the prices down. So when there is abundance of renewables, so lots of wind, lots of sun, you will see low and even sometimes zero and negative prices. And they increase year on year. I think if you would make a business case 10 years ago or even 5 years ago for an electric boiler, for example, there would be no business case. The prices would not be lower than fossil. But today you do see, I think, let's say about 1,000 hours or 1,500 hours that you could operate your electrical asset, your electrical boiler, instead of your fossil gas boiler.
Yeah,
and that's cheaper.
Yeah, and that is when you look at the spot markets, the day-ahead market, then typically 1,000 to 1,500 hours per year, electricity is cheaper than gas, and that would make sense to switch on the heat boiler and turn down the gas boiler. But there are other markets, like for instance, if you would more look like imbalance pricing, then it's even more, then it's maybe 2,000 hours per year already. So it is interesting, it is evolving. The difficulty in predicting where it really goes is that, as always, prices is a balance between supply and demand, and both evolve. So the more negative prices, it will attract electrification, which then will compete for the cheap hours. So the best remedy against extreme prices are extreme prices, sometimes economists say. So that balance, the market will find that balance. And in the transition period, the next 10, 15 years, it will be sometimes a bumpy ride. But the opportunity is clearly there. I remember that 10, 15 years ago, when it became clear that renewables would be the driver of, and actually the savior of the energy transition, immediately we knew that there will be a problem with balancing that system. I was expecting that already 5 or 10 years ago, that we would see volatility in spot prices, but we didn't see it coming, and it was actually only since, I would say, 2021 or something that it really became volatile.
But we are now just talking about the difference between electricity and gas prices. But suppose a company wants to really stop completely with gas, what options do they have then?
Well, I think too, and then maybe Jens, you can comment on that because you were working on a case. But in general, you have two types of arbitrage mechanisms. You need a choice. If you don't have a choice, you cannot optimize. So the first choice is that you choose between gas and electricity. That's arbitrage between markets. That's what we gave in the first example. But if you only have electricity or you don't have that possibility, there is another type of arbitrage that's shifting in time arbitrage. So consuming when prices are lower, and then there are different mechanisms to that. But maybe, Jens, you can give a concrete case.
Because we were talking previously on an e-boiler case. So that's, I think, something what you see in industry today is that they're complementing their fossil-fired boilers with an electric boiler. So they just put an extra one on the side, and they have the option to choose between electricity or fossil gas to make their heat. That's what you see today. And this way, you indeed have an arbitrage between energy markets, so to say, the fossil gas market and the electricity market. Another option is if you go fully electric, which means not just complementing your existing system with an electric boiler or another asset, but really getting rid of the fossil fuel altogether. Then you could put a storage there. You put something in between your heat producing asset and your processes which consume heat. You put a storage in between, and then indeed you can shift in time, as you say, Jeroen. So this means that you can then just absorb electricity from the grid or local when there is abundance, when there is not lots of wind, lots of sun. You store it, you buffer it, and then you can use it later on when you require it for your process. I think those are two main options. And I think today we mostly see the first one, the energy market arbitrage. But I see in the coming years, or when the transition progresses, that we will shift to fully electric industrial sites, and then you will need these buffers.
Which factors will push this drive? Because if you're now not really seeing those full electric plants, we might be seeing them in a few years. What factors will drive this?
Yeah, I think it will be cost indeed. As we said before, electricity prices today are almost twice as expensive as fossil. So if you would electrify your industrial site today, you would be paying twice as much. If you would consume like a baseload electricity in your e-boiler for your heat, and then it's just a matter of business case for the storage.
Yeah, and of course, if you would, you could say that an e-boiler has a COP of 1, so 1 megawatt hour of heat is 1 megawatt hour of electricity, more or less. Of course, if you could go to heat pumps, which is technically it is feasible for low temperatures since many decades. It is now already feasible for, I would say, the lower temperatures, like say 100 degrees or a bit more. Very higher temperatures, it's challenging, but it will also come as the technology gets more mature. And there you have a COP of, let's say, 3. So that means that you consume only 1 megawatt hour of electricity to replace 3 megawatt hour of gas. And then if gas is twice as expensive, you still win. And so that is the business case of a heat pump. But we do have a customer who has several heat pumps with several heat buffers. And so you can improve even further. The heat pumps alone have a business case, but you can improve the business case by also involving the buffers in the steering of the heat pump. And so when prices are low, you push the buffers and make them as full as possible. And when prices are high, then you try to turn down the heat pumps and use the capacity stored in the buffers.
Yeah. Okay, but you said that this would be possible for rather low temperatures.
Yes.
What could be used as a buffer for very high temperature? I'm talking about steam. Are there already solutions? What do you think?
Yeah, we are looking into that. It's not, I would say, today commonly widespread, but typically there are systems which can work as a steam buffer. So high temperature, let's say 300, 400, 500, 600 degrees. Sometimes they say hot rocks in a box. That works. You can just, if you have a high temperature heat source, you heat up hot rocks in a box, and then later on you get them out. Okay, technologically it's a bit more complex, and especially when there is steam involved, because the thermodynamics of steam have their own difficulties. But we are looking into customers to store heat in heat storage. And actually, the good thing about heat storage is it's less capex intensive than, for instance, lithium-ion batteries. The only thing what is hindering now, I would say, is that it's not fully matured, but I think in 2-3 years that already will have changed.
Yeah, but I think heat storage is a very important topic. That's why I think we'll discuss it in another episode of the podcast.
Yes, so let's dive deep. Yeah.
All right, but then you are now talking about companies now have a gas boiler. They can install some electric equipment like an e-boiler or a heat pump. They might need to design buffers to make use of the volatile energy prices. So this is quite an engineering problem. I believe it's called a design for flexibility. And let's talk about that, because you sometimes hear of this concept, but why is it important?
Well, I think it's a good point that you bring, because when we take the example of the heat pumps and the buffers, if you would not design for flexibility, you would typically design your heat pump based on your average heat consumption of your process. And then the buffer would be there, maybe for technical operational reasons, because your consumption of heat is not base load, but is peaky. And with a well-designed and well-sized heat pump, you can then just provide your heat. But if this is the case, then your heat pump will need to be operating 100% of the time. And in fact, you don't have that much flexibility. So design for flexibility is more, could we maybe increase the nominal power of the heat pump, increase the size? And this way you have the option to sometimes switch it off and sometimes produce a bit more heat and store it in a buffer. So that's, I think, an example of design for flexibility.
And it goes a bit against the intuition, especially for base load operating industries like chemicals, petrochemicals are typically very capex intensive installations, and they were and have been designed for base load operation. And by default, if something is 100% loaded, there is no flexibility. And then so it is a bit counterintuitive to run capex intensive assets, I would say, at not at full capacity. So design at a higher design point than what is actually on average needed. But we can just make a business case, and sometimes the additional capex is worth it, and you don't have to over dimension everything. Typically, the heat pump can be a bit bigger, but also, for instance, the hot water tank, instead of 100,000 liters, put 200,000 liters. It's not a big impact on capex, while it gives a lot more megawatt hours that can be stored in that buffer. So, design flexibility is a bit of a mindset. And it's not possible for everything. But yes, on sub-processes level, it's almost always an option in a business case to do something.
Yeah. And it's also, I mean, I do not know how many engineering companies are really into design for flexibility. But what we see, of course, is that you have a lot of possibilities today where flexibility in processes can be, let's say, valorized just by introducing the right control. If somebody just places an e-boiler next to a gas boiler, it's not so difficult. But if you want to go for the, let's say, the big chunks of flexibility, a bigger number of megawatts that can be used, then the initial design of companies needs to change.
Yeah.
And today I have not really the impression that a lot of companies are doing this.
Yeah, it's also because in the past the price signals were not there, and that is really something of the last years. And so, of course, new designs, new plans, it's typically a long term, so it takes a few years before something gets operational. I hope engineering companies start to take it into account. We do at least what we call the sizing problem of things. Having said this, often there is also let's say operational buffers or capacity in existing assets which have been paid for, sunk costs that can provide flexibility, and then you have a zero capex entry into flexibility. Sometimes also I think also in designing and engineering, it's a mindset thing. You have to think a bit differently, and this is why we see customers that typically start with a no investment case. So just take an existing flexibility or an existing asset that we can use flexible, have some experience, 1 or 2 years, see in practice the value, the impact on the energy bill that comes. The operators also that maybe in the beginning say, well, let's steering dynamically. It's another complexity we add on top already on a complex job. But once typically people get acquainted, have experience, it works. But I think that's where Entras and the software of Entras comes in. Yeah. You have to protect the process. You have to respect the boundaries. Very simple. If you have a heat buffer, you need to predict when the buffer will be full and when it will be empty. And also in real-time operation, you have to monitor if your prediction is still maintained, because what you don't want is to bring the process in trouble, of course.
Yeah. All right. So that's where predictions and artificial intelligence are introduced into the equation.
Yeah, absolutely. I think and data, before you can apply artificial intelligence, what you first need is the data. So, but okay, I would say in general, normally the industrial, at least in this segment, there is data. You just have to unlock them, standardize them, and
exactly.
But yes, maybe on artificial intelligence, I think there are other. It's not only about predicting and forecasting, but also we use it internally. Also in our software to make better optimizations, I guess.
Yeah, sure. One example, and we're always talking about heat. That's maybe also because when we talk about electrification industry, energy consumption industry is typically heat-driven. So that's maybe why we always talk about heat. But let's then continue to talk about heat. Heat consumption is not always baseload. It can be a peaky profile. It can have some certain profile linked to production planning, linked to, I don't know, outside temperature, something else. Machine learning could be an interesting way in predicting how this heat pattern looks like. And that's then, of course, interesting. So it can feed back into the optimization and feeding back into, okay, when can we use the buffer? Should we have some safety margins, yes or no? Maybe they should be dynamic over time. So I think definitely AI, machine learning and stuff is increasingly important in steering optimally.
Right. Yeah, maybe a small anecdote on that one. I do remember a few years ago, we were optimizing an electrolyzer, and then the algorithm was optimizing clever stuff. And then we looked at the results, and then we saw, the algorithm is steering first the least efficient cells. So it's not possible. We should always first prioritize the most efficient. But then we noticed, the prices were negative. So it actually makes sense that if prices are negative, that you use your least efficient processes, because then you consume more and you earn more money.
All right, this reminds me, if we go back to the business case of industrial electrification, making use of negative prices implies that you have a contract that allows you to do it.
Yes.
So let's say, I believe still some industries work with, let's say, fixed prices over a certain period. So I guess those industries might think, electrification, negative prices, volatile prices, that's all good, but we cannot use this in our business case because our contract does not really allow us to make use of it.
Yeah, to an extent, I guess that is true or was true. I think that is changing now. Most of the industrial customers, at least, they are exposed to spot prices in new contracts, just because energy suppliers, they cannot take this full volatility risk into their profile. So contracts, as maybe you still have what they call a full flex contract with fixed prices somehow, but they are all fading away. So if you renew the contract in industry, typically you will get at least spot prices. So actually, at Antras, we are not a supplier or an aggregator. We work on the contracts that our customers have. We check, of course, if these contracts are spot price exposed, for instance. Otherwise, it doesn't make sense. But I would say that is not the issue, because new contracts are always spot price exposed. If you want exposure to other market products, you need an aggregator, or if you want exposure to the imbalance prices, you have to nominate. All a bit of complexities, but can all be done. There's maybe one big misunderstanding, which is sometimes people say, but I've hedged my energy. I bought, I already clicked the price for next year for my electricity, so it's fixed. Well, actually, it's not true, because when you buy something on a future, on a hedge, you hedge, you're not only fixing the price, you fix price and quantity. And so any deviation from that quantity you have hedged is at spot price. So even if customers have a portion of their energy hedged, typically they are still exposed to spot prices. And so at Antras, we don't even have to be energy suppliers to optimize our customers' flexibility potential. We can still do it.
And those spot prices, would playing on the spot prices, would that be enough to make a positive business case for instance, if you place an e-boiler next to a gas boiler, or would you need other income from flexibility?
Well, that depends a bit. If you want to comment.
I think it depends. As said before, I think 5 years ago, the business case would definitely not be there. But we see year after year, the amount of electricity prices which are lower than the fossil gas price becoming increasingly larger. So it's 1,000 hours, it's 1,500 hours. Maybe next year it's almost 2,000 hours. We have no crystal ball, but we know that it will be increasing. But to answer on your question, is it possible to have a business case purely on the spot markets? I think it depends. It could be that today there is not really a business case and you need some additional income, and you could reserve part of your e-boiler, or you could sometimes steer it on those ancillary services products. So meaning that you sell your flexibility to the system operator, so they can use it to balance the grid, and you're paid for that. That's something like an additional service, and that's possible to do next to the spot optimization or the steering on those hourly spot prices.
And so industrial parties that do not have experience with this kind of ancillary services, how can they start with it, or how can they know whether they can do it or not?
Well, first of all, it depends. Technically, operational, is it possible? So we talked a lot about e-boilers. So that's making heat with an electric resistor or with the resistance of the water itself. This is something which is very dynamic, and this is technically possible to supply this service. Yeah. But of course, it depends on the asset. So first you have to know that it's technically operational possible, and then you have to go find a party who can put it on the market for you, or you could do it yourself. So as discussed, we call it ancillary services. So it's something that you offer. It's a service to the system operator. You could do it directly. It's a market, and you can place bids on the markets, etc. But you do have other parties doing that for you. And the aggregator or the BSP, the balance service provider, is a party who looks for this flexibility, aggregates it, and offers it on the market to the system operator.
Yeah, and I think that is a good solution, especially for, I would say, the mid-sized companies. Not, I think the huge companies, they can probably do it themselves because they are so energy intensive. But a lot of, let's say, food companies, which are not the most energy intensive, but rather energy intensive, they can very easily access this market. And I would say the innovation we do at Entras is that instead of fixing the megawatts for the next year in the contract with the aggregator, is that we try to make it dynamic and that we communicate every day to the aggregator how much megawatts are available for the next day and how much upwards, how much downwards, because the amount of megawatts available for a balancing service with the aggregator depends on the spot prices, depends on the process planning, depends on the state of the factory. So typically first we optimize that, and after that optimization we know what can still be done. And sometimes some flexibility is just not in the money in the spot market. Let's say a steam turbine that is running on part load, it needs often so high electricity prices before going to full electric mode that purely on a spot market optimization you don't activate the steam turbine. But that is ideal to offer then in one of these products, the slower activation, the MFRR product. You are paid to be there rather than to be activated, and you are very rarely activated. Let's say every 2 weeks you're activated for a few hours. You get a bit money from that, but the big revenue is not the fact that what you get for these few hours. The money you get is what they pay you as an insurance premium to be there, the reservation fee that you are paid, and that can be good, interesting combinations.
And another point that makes a business case often difficult is the connection.
Yes.
So a company that has a certain electricity connection, normally they use a capacity, then they want to install extra electrical equipment. Suddenly the capacity needs to be a lot bigger.
Yes.
And then they run into problems like, first the grid operator needs to confirm that there is enough free capacity. That's one thing, and then there is the costs of the new connection.
Yeah, the two difficult topics indeed. It is true that if an investment, let's say an e-boiler of 10 megawatts, would require an additional cable, additional medium voltage equipment, and maybe an additional contract or even work into the streets from Elia or Fluvius or the grid operator, then it's quickly a few million of euros, and then suddenly the business case can be difficult. Of course, you could argue, is that capex only for that e-boiler, or is that also for the future electrification of the factory? So that there is the capex part, but that's true. It can be significant, and there's also waiting times, so it's not so easy. The second aspect, it's more of an optimization problem. It's the grid tariffs, and they depend strongly on region, also on voltage level. But it is difficult also. I would say it's a challenge to take it in the optimization, because it's not only so many euros per megawatt hour you pay for every when you use the grid. It's a complex structure of tariffs, and you pay for the peak and you pay for the capacity. And for instance, the peak, if you have to pay for the monthly peak, our optimization algorithms cannot forecast a month, so it's very difficult. So also from an optimization standpoint, it's quite a challenge.
Yeah, of course, but in some cases there are other reasons for a peak.
Yes,
and then the heat pump or the e-boiler might not introduce the only peak in a month, and then of course this cost cannot be attributed to the heat pump.
Yes,
and then an optimization might be easier.
Yeah, but it is complex, and at some point you enter into the discussion: is this peak? Who causes it, and on which PNL does it have to be written? Same for the capex. Is the additional millions for the grid connection, the capacity increase? Is it related to that e-boiler, or is it maybe related to the future investment plan of the factory to become carbon neutral on the long run? That is always a bit of discussion.
Yeah, and a thought that I recently had, you hear talking about flexible connections, where you get the power you want, but maybe the grid is not capable of always at any moment in time delivering that capacity. So then typically what happens is they will say to you, you can get a connection, but in X%, and the X is then maybe 5% or so of the time you could be shut down, or your connection could be lowered to some level.
That, for instance, personally, I don't find a big problem. I prefer that there is a grid connection, which maybe in the first years is a flexible one and not fully, because we can take that into account in the algorithm. We know that, okay, in case you are curtailed somehow for reasons in the grid, typically, okay, you lose a few percentage on your revenues, but it does not kill a business case. Typically.
What I was thinking is there are processes that can really not be without electricity. Like, for instance, certain chemical processes that need electricity, or heating processes where you have an electrical oven to melt materials. But if you have today, if you have like a gas boiler and next to it an e-boiler or a heat pump, if the connection goes down, you can immediately start up the gas boiler and maybe compensate. And then these types of solutions can be the point for industries to get a higher connection at a more affordable cost and have a positive business case for the electrification.
Yeah, I think so. It's really a match, in fact. Well, the matter that there is a flex connection is because everybody wants to electrify. But you electrify with, indeed, for example, placing an e-boiler. When do you want to operate it? When there is abundance of wind and sun, when the prices are low. And that's typically not the moment, probably, that you will be shut off, or that your connection will be lowered. So typically, I think there is a good match between if you want to increase your capacity, and it's a flex capacity, and you use it for electrification purposes. And so assets that you assume could be lowered without any significant impact on your process. I think this is a really good solution, in fact.
And maybe it brings, let me bring it back to the value proposal that we have as Entras. What do we optimize at Entras for industries? We optimize what we call behind the meter multi-asset. So we take into account the grid connection, and it is multi-asset, so there's typically more than one options to make heat. Can heat pump, e-boiler, gas boiler, CHP, they all compete with each other, I would say, at the same site, and you use them in which one of these assets do you use first? And it is often related to this. Why is the behind the meter important? Let's say that if you would switch on your e-boiler because wholesale market prices are low, you could switch on the e-boiler, but it would induce a peak, which would be so high that actually you don't want to do it. That would kill the e-boiler case. But if you have a CHP that is running anyway next to that CHP is producing electricity. If the e-boiler is using the electricity from the CHP, then you don't get a peak from the grid. And this is how several assets behind the meter somehow have a different optimum than if they would be all separately. And that is exact. Of course, it's not so intuitive anymore, and Excel will not do the trick anymore to figure out what is the best possible combination of assets in real time also. But this is exactly what we do with the software of Entras.
Yeah, I fully agree. And it could be a CHP, but that's still fossil gas then probably. But it could also be a wind turbine on site. It could be PV on site. So indeed optimize all the assets. And its assets is both producing electricity, but also consuming electricity.
Yes, and then adding to that, it's not necessarily on site, because if you could have PV on your rooftop of the factory, but you could also have a PPA, power purchasing agreement, and if it is I would say a hardcore PPA that you buy the real profile, then the wind turbine of the solar panel will be not physically at your asset. Maybe it's not owned, it's most of the time not owned by you, but you buy the full profile. That it's as if this energy is on your site and has to be taken into account in the optimization. Of course, it will not induce peaks in the tariff structure, but it will change the optimum of what is behind. So also PPAs have to be taken into account and into the optimization problem.
Yeah.
All right. So we started with a business case of industrial electrification, and with the possibility to use e-boilers, heat pumps next to a gas boiler with arbitrage. Then we went on a big deal of the role of, let's say, everything that has to do with tariffs, capacity, flexible connections, grid tariffs. And I believe as well that the specificities of any industrial case are really important, because any process, no process is exactly the same as another one, and you have other peaks or a baseload behavior, and all those little things make or don't make a business case.
Yeah.
Would you have a final comment on that?
Well, I would say what is interesting is also the longer term. If we are talking about energy transition, you're not doing it. I know that you preferably have a payback of a few years, but it's also about resilient in the longer term. And then it's interesting to think about what will happen on the longer term. And the first element is that these clean spark spreads, so the average difference, the difference between the average electricity and gas price, they will be smaller and smaller. So electricity on average becomes cheaper and cheaper just by the fact that there is more wind and solar. So in the long run, electrification will always become more interesting. And the second one is, I think it's important to look at spot markets. I know that for flexibility, the biggest value was often in these grid balancing services. But on the longer term, it will probably in the spot markets, because these grid balancing services are shallow markets and there will be competition with batteries. And while on the spot market, that is a deep market. And for the next 10, 15, 20 years, we will have gigawatts of especially solar, also wind, but mainly solar, that will be pushed into the system, that will create volatility. And that volatility, you will see it first and foremost in these spot markets. Right. So, and actually the spot markets are great for industry, because that is a day ahead plannable event. It's not mandatory. It's activation unexpectedly and so on. So I would say on the long term, it will only get better with the electrification.
Right. Jens, do you have a final comment?
Well, yeah, I fully agree with it. I think to go further indeed on this renewables, we have lots of wind, lots of sun, lots of PV panels, lots of wind turbines. It's all non-dispatchable. So we have the electricity when there is sun. We have the electricity when there is wind. And on the other side, we have the consumption side, and industry typically consumes baseload. So I think the challenge that we have is to maybe also convince industry that maybe we should adapt a bit on when is the electricity available. And the sun only shines during the day and not during the night. Well, maybe then we should look into how can we take up this massive amount of electricity that will be there in the future or even today, store it, buffer it, or use it usefully during the day and maybe a little less during the night.
All right, clear. And it starts always with somewhere a company that takes a decision about maybe one asset, but that's how we will grow. And eventually Belgium and maybe Europe will be capable of dealing with all those renewables.
Yeah, I'm pretty convinced that we will. And now we harvest, I would say, the easier parts and don't touch immediately on the full factory, of course, because but as we gain more experience, as this volatility becomes bigger, we will slowly get there. And we follow the pace also of what is happening in with renewables, just we follow. And I think industry will take also its responsibility, and not only responsibility, also the opportunity of that. Yeah.
Yeah, all right.
Well, at the end, for the industry, it's a business case.
Yeah, it's a business case, and I like business cases, so that's perfectly fine.
That's maybe a very good end to this podcast.
Yes. Okay.
Thank you, Jeroen.
Thanks.
Jens.
Thank you.
Bye.
Bye.